Okay, picture a map of India in your mind for a second. To the north, you've got the towering, majestic Himalayas, capped in all that ice. Then down to the south, you have this vast, triangular, peninsular plateau. Now here's a bit of geographical trivia for you. Which of these two regions has the older river system? Honestly, you'd probably be tempted to say the mighty Himalayas, right? I mean, given their massive scale and just how famous they are. But, actually, scratch that, you'd be wrong. The real answer is hidden deep in the south, etched right into the ancient bedrock of the peninsula.
Welcome to this explainer on India's hydrology. Today, we're taking a really epic journey across the subcontinent. We're going to look at how time, geology, and gravity have quite literally carved the lifelines of an entire nation. We'll be exploring the massive, chaotic rivers of the north and then contrasting them with the totally grounded, ancient river systems of the south. Okay, let's dive into this.
So here is our roadmap for today. First, we'll meet the turbulent youth, the mighty Brahmaputra. Second, we pivot down south to the wise elders, the peninsular rivers. Third, we're going to uncover 3 epic geological shifts. Fourth, we look at the eastward flowing giants. And fifth, the western rebels. Finally, we'll tie the whole shebang together with a concept called the Thalweg. Part 1. The mighty Brahmaputra, the turbulent youth. Let's start with our very first main character, the mighty Brahmaputra. You know, if rivers had personalities, this one would for sure be a restless, wildly dynamic teenager. It's one of the largest rivers on the planet, and it just absolutely refuses to be tamed. Before it even touches India, it has this legendary origin story. It starts way up high in the Kamayungdong Glacier of the Kailash Range. For almost 1,200 kilometers, it flows east through the dry, flat plains of southern Tibet. Up there, it's actually known as the Tongpo. Now, Tongpo literally translates to the purifier, but, well, it doesn't stay a calm purifier for very long. All of a sudden, the river violently pivots and carves this ridiculously deep gorge. We're talking 7,755 meters deep, right near Namchabarwa. It basically crashes into India as this turbulent force called the Siang, or Dihang. As it aggressively pushes southwest, it absorbs these massive left-bank tributaries like the Dibang and the Lohit. And it's only right then that it finally takes the name Brahmaputra. Tearing through the Assam Valley for 750 kilometers, fed by rivers like the Subansiri and Manas, it's just constantly shifting. By the time it hits Bangladesh and the Teesta joins in, it becomes the Jamuna. Because this system is so intensely youthful and full of unbridled energy, it is infamous for massive floods, wildly shifting its channel, and tearing away at its own banks. It's literal chaos in motion.
Part 2. The ancient peninsular rivers, the wise elders. Okay, take a deep breath. We are leaving the chaotic flood-prone north behind and traveling all the way down south to the peninsular drainage system. If the Brahmaputra is a restless kid, these rivers are the wise, deeply grounded elders. Now what's really interesting here is the stark contrast. While the northern waters are constantly shifting and flooding, these southern peninsular rivers are mature. They have broad, shallow, largely graded valleys. Their courses are basically fixed. You absolutely won't find those wild, winding meanders down here, and a lot of them actually have a non-perennial flow, which means they rely entirely on the seasonal monsoons. They're significantly older, totally settled, and carved deep into ancient rock. So why is that?
Part 3. 3 epic geological shifts shaping the peninsula. To really understand why these older rivers behave the way they do today, we need to play geographical detective and look back into deep, deep time. The shape of these rivers wasn't just decided overnight. It was dictated by 3 absolutely epic geological events. Let's walk through them. Step 1. Way back in the early tertiary period, the western flank of the peninsula literally just subsided and sank below the sea. That permanently wrecked the original watershed. Step 2. The massive upheaval of the Himalayas. When those northern mountains violently pushed upward, the northern flank of the peninsula block cracked under the stress, creating these deep trough faults. And then, step 3, which is honestly the most crucial one for our story today, the entire peninsular block tilted just slightly from the northwest down to the southeast. That one single massive tilt basically set the permanent rule for the region's hydrology: you must flow toward the Bay of Bengal.
Part 4. The eastward flowing giants, sharing the land.
Because of that massive northwest to southeast tilt, the vast majority of these peninsular rivers flow east, finishing their incredible journeys in the Bay of Bengal. Let's meet the biggest of them all, the Godavari. It's often called the Dakshin Ganga, or the Ganga of the South. Rising in Maharashtra, it stretches an insane 1,465 kilometers. And this river literally divides and shares the land. If you look at its catchment area, almost half of it, 49%, is in Maharashtra alone. But it's also deeply sustaining Andhra Pradesh, Madhya Pradesh, and Chhattisgarh. It's just this incredible unifying force across the states.
Right just south of the Godavari's basin, we hit the Krishna River. This is the second largest east-flowing peninsular river, born in the Sahaju Mountains. Even though it originates in Maharashtra, a huge 44% of its catchment area is deeply tied to Karnataka, before it pushes through Telangana and Andhra Pradesh. It's fed by major rivers like the Koyna, the Tungabhadra, and the Bhima, coming together to create a vital 1,401-kilometer lifeline.
Then we have the Kaveri, rising in the Brahmagiri hills of Karnataka. Now, the Kaveri has this fascinating superpower compared to all the other southern rivers. Remember how I mentioned that peninsular rivers are usually non-perennial? The Kaveri is the big exception. It actually carries water all year round with way less fluctuation. And the reason is so cool. Its upper catchment gets slammed by the southwest summer monsoons, but the lower part catches the northeast winter monsoons. So it's geographically blessed with 2 rainy seasons, keeping Tamil Nadu, Karnataka, and a tiny sliver of Kerala hydrated all year.
So the crucial point is 851. That massive number represents the length in kilometers of the Mahanadi River, which drains heavily from Chhattisgarh straight through Odisha. Over half its basin sits in Madhya Pradesh and Chhattisgarh. Together, these giants completely define the eastern landscape. But, in geography, there's always a rebel.
Part 5. The Western Rebels flowing backwards.
Because, naturally, not every river follows the rules. While the rest of the peninsula obeys that great southeastern tilt, we have a few totally rogue rivers that seemingly flow backwards. Think about the physics for a second. If the whole continent is actively leaning toward the east, how in the world do major rivers like the Narmada and the Tapi flow west into the Arabian Sea? There's no way water flows uphill, right? So what on earth is letting them defy the tilt of an entire continent?
Well, the answer takes us right back to geological step number 2, the upheaval of the Himalayas. When the north cracked and subsided, it left these massive trough faults in the earth. The Narmada and the Tapi are basically trapped inside these ancient rift valleys. They're flowing through deep, geological scars that just happen to cut completely against the grain of the continent. And because they're stuck in these hard, rocky faults, they don't fan out to form those sprawling, muddy deltas in the east. Instead, they just fill the original cracks with detritus. Structure dictates flow, every single time.
Let's look at these two rebels side by side. The Narmada is definitely the bigger of the two, bursting out of the Amarkantak Plateau at over 1,000 meters high. As it aggressively flows west for over 1,300 kilometers, it carves out these unbelievably picturesque landscapes, like the famous Marble Gorge and the Dhuandar waterfall. The Tapi, on the other hand, starts in Madhya Pradesh. It's shorter, but it's equally defiant, draining almost 80% of its basin from Maharashtra before finally pushing out into the Arabian Sea in Gujarat.
Oh, and we definitely can't talk about Western rebels without mentioning this wild outlier, the Luni River in Rajasthan. It originates near Pushkar from two distinct branches. It flows west, but get this, it never even reaches an ocean. The Luni is an ephemeral river. It flows west, takes a hard southwest turn, and then it literally just vanishes entirely into the salty marshes of the Rann of Kutch. Absolutely fascinating.
Part 6. The lowest point. Thalweg, finding the way home.
So, let's move to the grand finale and see how this all builds together. We've seen these youthful, chaotic rivers violently carving through mountains, and we've seen ancient, wise rivers flowing gently along a tilted continent or hiding inside deep rift valleys. But no matter where a river is on Earth, it is governed by one universal, invisible rule, the Thalweg. In geomorphology, a Thalweg is defined as the continuous line of lowest elevation within a watercourse. Whether a river is wildly shifting its banks like the Brahmaputra, or locked into a rigid fixed course like the Godavari, the water is blindly, relentlessly seeking out this exact line. The Thalweg is just the ultimate destination that gravity demands.
Which brings us to a final thought. Over millions of years, through massive geological upheavals, shifting continents, and tilting landmasses, the water has always patiently found its path of least resistance, its Thalweg. The rivers of India are essentially a physical map of deep time. They're a story written in water and stone. So if the landscape of an entire subcontinent can be so perfectly, patiently shaped by the invisible forces of gravity and time, what invisible forces are shaping the landscape of your own life? Thank you so much for exploring with us today, and keep seeking out those deeper currents.